Okay, good afternoon, class. We're going to start the Matlab section of the course today. In today's lecture, we'll just go over some very basics. I'll show you how to set up the Matlab environment. We're going to create a vector. Then we're going to look at exponentiation or operating mathematically on that vector. And then we'll do some very simple plotting. So the first thing we'll do is I'll go down here and grab Matlab. And here we see the command window. So what I want you to do is go ahead and record all of your keystrokes. So we'll say diary, and we'll just put test1 as the file name. Now I've already got a test1. Let's put this as test2, and we'll see it come up over here. Now the first thing that you're going to want to do is to set your file path. So if you're working on the systems in the engineering lab, I expect you to probably work from your flash drive, which is what I'm doing here. So just open it up and browse it. So I'm using my Lexar flash drive, and I expect you to do the same. It'll keep you from losing files on the hard drives in the lab. So let's look at creating some vectors. So the first way I'm going to show you to do it, and in Matlab there's always going to be multiple ways. So let's create a vector x, and it's going to go from 1 to 5. So I'm going to say x is equal to 1. We'll say colon 5, and now if I don't put a semicolon on the end, it's going to basically mirror all the commands. So here we see a vector x with 5 entries, 1, 2, 3, 4, and 5. Now the second way I want to show you how to do this is I want to create a vector x from 10 to 25, skipping 5. So I'm going to say y is equal to 5, 5 colon, now I'm going to skip 10 colon 5 colon 25. So I should have 4 entries in y: 10, 15, 20, and 25. The third way that we can create a vector is the linspace operator or function. So I'm going to say z is equal to linspace, Linspace, and these commands can be found in your ebook resource on the Blackboard site. So on this one, I'm going to go from 0 to 2 pi, and I'm going to have let's see, 8 different entries in there. So I'm going to close parenthesis, and I've got a syntax error, and that's not going to be unusual. So let me do it again. I'll say z is equal to linspace. Now it's not a square bracket, it's an open parenthesis, so I'm going to say from 0 to 2 pi. And again, I want 8 values. I'll close the parenthesis and hit return, and there are my values. Okay, so let's do something a little bit different. Let's do a vector t, and let's do it for values of 1, 2, 3, 4, 5, 6, 7. So you can always input these 1, 2, 3, 4, 5, 6, 7. Now what I want to do with this is write a function ft that's basically x squared plus 3x minus 10. So I'll say ft is my variable name, and that's equal to x. Now to access each one of these separately, I need to put a dot operator, and we'll see what happens when I don't. When I do just x squared minus 3 times x minus 10, let's see what happens. Yeah, inputs must be a scalar and a square matrix, so I'm going to use the dot operator. So watch what happens. I'm going to say ft. Now to access each one of these vector components singularly, I'm going to use a dot right after the variable. So I'll say, oh, it's t. So I'm going to say t dot squared minus 3 times t minus 10. And there is my function. Now let's see if we can plot the function. We'll hit do a simple line plot. So we'll say plot, open parentheses, and we want the variables now, and it'll tell you what it wants. It wants the x-axis variable, so that's going to be t, and then the y-axis variables, which for us will be ft. So we'll just plot t comma ft, close parentheses. Now it may take a second for this to come up, but here we see that this auto scales this from 1 up to 7. Now what we'll want to do next time is learn how to modify these axes and put a plot name on this and everything. Guys, that's going to do it for today. Please be sure to do the reading assignment and looking at 2D arrays and more significant plotting next time. Thank you.